Welcome to Understanding Applied Statistics, Processing with SPSS, Chapter 5, ANOVA, Analysis of Variance. In this module, we'll take a look at techniques for comparing more than two groups of continuous variables. Suppose we have a study that involves three groups. Group 1 is the control group, Group 2 receives treatment A, Group 3 receives treatment B. Now, when we had the t-test situation, we were talking about two groups, Group 1, Group 2, and with those two groups, in terms of comparisons, there was only one comparison that could be made, Group 1 to Group 2. As we move into ANOVA, we're talking about more than two groups. So let's bring in a third group. When we have more than two groups, in this case 3, we can not only compare Group 1 to Group 2, but we can also compare Group 1 to Group 3 and Group 2 to Group 3. The ANOVA will help us discern which group is performing statistically significantly different from which other group. Let's continue with the agricultural example that we set up in Chapter 4. Group 1 receives water on a row of corn. Group 2 receives crop charger on a different row of corn. And now, Group 3 will receive a new growth agent, chemical Q, on a third row of corn. 10 stalks in each row. A month after planting, we'll measure the height of each stalk and use ANOVA to compute the scores. See if there is a statistically significant difference in the performance among these groups. We'll go into SPSS and look at the setup. As you can see, there's two variables, group, which is categorical, and height, which is a continuous variable, recording the height of each corn stalk. Just to reveal the categories, we see that we're using 1, 2, and 3 for the corresponding groups. We'll go into Analyze, Compare Means, One-Way ANOVA. We'll place the group variable into Factor. We'll place height into the dependent window. At this point, we'll select a post hoc test. Since all of our groups have 10 elements in them, we'll select Tukey. If our groups aren't so balanced, we would select the Sidak test. Click Continue. Now, under Options, choose Descriptives, because we're going to be very interested in the means, and Means Plot, so we can see a graphical representation of the means of each of the three groups. Click Continue. Click OK, and it processes. The first set of table we look at is the descriptives. We see here water, 10 stalks of corn, a mean of 34.4. Crop charger, 10 stalks, mean of 38.8. Chemical Q, 10 stalks, a mean of 40.1. First place we go after that is the ANOVA table. We come to the sig value, the P level. This is 0.008, which is less than the 0.05 alpha level, telling us that we have a statistically significant difference in the ANOVA, which translates to telling us that somewhere among these three means, something is statistically different from something else. For further information on what's different from what, we scroll down and we examine the post hoc test. This table is double redundant. I'll show you what I mean as we go along. We begin by examining water against crop charger, Group 1 to Group 2, and we come over here to the sig value, 0.048. telling us that there is a statistically significant difference between water and crop charger. The next comparison is water to chemical Q. P level, sig, 0.009. Again, less than 0.05 alpha level, therefore, chemical Q to water, statistically significant difference in their mean heights. The next entry is crop charger to water, which is 0.048 for the statistically significant difference. However, we already compared water to crop charger This is why we're seeing the 0.048 a second time. As I said, this table is double redundant. To move on to the last unique comparison here, we want to see Group 2 against Group 3, crop charger against chemical Q, 0.743 for the significance level. This is greater than 0.05, so we would say that there is not a statistically significant difference between the performance of crop charger compared to chemical Q. The last thing we look at is the means plot. This is revealing. It shows water coming in at a mean of 34.4, which, according to our table, showed that it was statistically significantly different from crop charger, which came in at 38.8. The second comparison it made was water to chemical Q, which was 34.4 to 40.1. Again, that produced a statistically significant difference. However, even though chemical Q outperformed crop charger, 40.1 to 38.8, we saw that this difference is not statistically significant. This concludes this module.